Welcome to the class, dear students. Greetings of the day. Today we are going to do the methods of integration. That is the chapter 1. So that means the topic is to find out the solution of an integral using different methods. So to understand this, just I want to explain you about what is meant by the antiderivative and then what is meant by the indefinite integral, and then we will enter into the methods of integration. So a function f of x is an antiderivative of the function f of x if you define that f dash of x is equal to f of x. This capital F of x is called as the antiderivative of this function for every x in the domain of x. So now when you take the derivative of a function, whatever the derivative you are getting, that is called as the other way is called as the integral of this function. Now indefinite integral means the set of all such antiderivatives of a function f of x is the indefinite integral of the function f of x, and we denote this as integral of f of x dx. Now let us enter into the methods of integration. In this you have the methods as term by term. That means the method itself says that we are separating the terms by term in the given integral, and then we start integration. And integration by substitution, that means whenever there is a function involved in another function, suppose, then we use the integration by substitution. And then the next one is integration by parts. So today's video I am just covering the term by term integration, how to solve the problem by using the method as term by term integration. So let us now have a look about the problems. Just I will start the problems, how to solve it. Now the first problem is, for example, if you have the integral as x square minus 2x plus 5 dx, suppose, then what we do, we just split this as integral of x square minus integral of 2x dx plus integral of 5 dx. What we do now is just take down the integral of x square dx. I hope the formulas are very clear. Integral of x power n is given by the formula x power n plus 1 over n plus 1 plus the constant. So this is what the formula we are using. And if you have any constant, suppose a times of x dx is there, means you will take a outside of the integral and then do the integration as x dx. So now we are going to do the problem for this as integral of x square means x cube over 3, x power 2 plus 1, that is x power 3 by 3, minus take 2 outside, and integral x dx becomes x square by 2 plus take 5 outside, integral dx is x plus the constant. So that gives you x cube over 3 minus 2 gets cancelled minus x square plus 5x plus c. This is what the solution of the integral. I hope it's clear how we have defined, we have separated each term like this and then solving the integral. That's the first problem. We will do some more problems to make you to understand how to solve this type of separating the problem terms in the integral. Let us now have another problem. Problem number 2 is, suppose you have integral of t root t plus root t over t square dt is there, suppose. Now how to write down the solution for this? So we have to split this as we write this t root t by t square plus root t by t square. So the method of splitting is like this. So t root t by t square plus root t by t square dt. So now how will we rewrite this one? So this 1t gets cancelled, right? So here we can see that 1t is t square, we can get that can get cancelled. So we can write it as root t by t plus, now root t by t square. So I hope you know what you write. Root t by t square means t into t. So now we know that what is t can also always written as root t times of root t. This I hope you know. So we can use that and we can write this as integral of root t over root t times of root t plus integral of root t over root t into root t into t, because 1t I am writing it as root t into root t. So this root t gets cancelled, one root t gets cancelled. So it will be remain with integral of 1 over root t, of course everything with the dt. So 1 over root t dt plus 1 over t root t dt. So now that 1 over root t means you can rewrite this as t to the power of minus half dt plus integral of t into root t means it is t power 3 by 2 when it comes to the numerator t power minus 3 by 2 dt. So now the formula is t power minus half plus 1 over minus half plus 1 plus t power minus 3 by 2 plus 1 over minus 3 by 2 plus 1 plus the constant. So now let us have a look about this. That is t power half by half and t power 1 minus 3 by 2 means minus half by minus half. So the value is t power half by half plus t power minus half by minus half plus the constant. So the solution is t power half. Whenever there is a denominator, in the denominator there is a fraction, we have to flip the fraction. So it is 2t to the power of half minus, this minus goes this side, so the minus of it is 2 times of t power minus half plus c. You can rewrite this as 2 times of root t minus 2 by root t plus the constant. So this is what the solution for the problem. I hope it is clear. Now let us go to the next problem. Suppose you have a problem like this. Third one now. Integral of cot square x dx. So in order to do this, I just give a small hint to remember the formula. Please remember the formula using some logic. Always remember, what is integral of sin x dx? This is minus cosine x plus the constant. And integral of cosine x dx is sin x plus the constant. See, remember, these two are one set of formulae where integral sign is minus cosine, integral cosine is sine. And next, how to remember the other formulae now. That is, suppose you have integral, the next equation, the next one is, for example, you have generally we follow with the order. Suppose this is what the order. Integral of tan x is there, and integral of cot x, and integral of secant x, and integral of cosecant x dx, of course. So for this, how to remember these formulae? These four are another set where you have all of them having ln. Okay, you have ln for all these four set of the formulae. For what? Tan x, cot x, secant x and cosecant x, you have ln. Okay, and always tan is a combination with secant and cot is a combination with cosecant. Let us remember like that. So tan x, integral tan x is ln of secant x plus the constant. Now integral cot x is minus ln of cosecant x plus the constant. Now integral of secant x you need, suppose. Now what is that? As I told, tan and secant are one set. So ln of tan plus secant x plus the constant. And for cosecant it is minus ln of, you can guess, right? Minus ln of cosecant minus ln minus ln of cosecant x plus cot x plus the constant. It is easy to remember, right? So what you have to get, see here, the first two are one set where integral sin x is minus cosine x, integral cosine x is sin x, remember. And there is these four are there, right? The four trigonometrical functions. For tan, cot, secant, cosecant, it starts with ln. For cot and cosecant there is negative signs. Tan and secant there is positive only. Tan and secant are one combination, as I told. For tan it is ln of secant. For secant it is ln of tan plus secant. And for cot it is ln of cosecant, and cosecant it is ln of cosecant plus cot plus c. This is what the way to, there is a logic to remember, right? So this should be done like this. And another special formulas are there for finding out is, for there is no square directly for the other functions except these two, integral secant square x and integral cosecant square x. So for square means integral secant square x is tan x, integral cosecant square x is minus cot x, of course, plus the constant. So this is what another set of two formulae where you can remember. So it is very easy if you understand this logic to remember this formula. Then we will proceed to do this problem. Now before going to do this problem again, now I wanted to write this as there are some trigonometrical identities. What are those identities? 1 plus cot square x is equal to cosecant square x. Okay, so you can write cot square x as what now? You can write this as, you can write this cot square x as integral of cosecant square x minus 1 dx, right? So now we know what is integral. Now you can split this as integral cosecant square x dx minus integral dx. So what is integral cosecant square? It is minus integral cosecant square we have done, right? The formula is what? Square. Cosecant square means minus cot x. So we will take this as minus cot x and integral dx is minus x plus the constant. So the solution for this is this one, minus cot x minus x plus c. This is what the solution. I hope it's clear. Now let us go to the next problem. The fourth problem is, you have, suppose, integral of 1 plus tan square x dx. So again the formula, there is a identity. What is 1 plus tan square x is given by secant square x. So we use that formula now to do this. So integral of 1 plus tan square x is given as secant square x dx, and we know what is integral secant square x. It is tan x. So now we write integral secant square x as tan x plus the constant. I hope it's clear. Now let us do some more problems like this. Integral of cosine x times of secant x plus tan x dx is there, suppose. Now again you need to remember the inverses of the functions also. What is that? 1 over cosine x is secant. 1 sine over cosine is tan. Sine by cos is tan. So these are what the two important relations. 1 over cosine is secant and sine by cos x is tan. So now how will you write this? Integral of, how we have to multiply, right? Cosine x with what we do here? We multiply this cosine x with the secant x plus cosine x tan x. So we will do now that one. So that is given by cosine x times of secant x plus cosine x times of tan x dx. So when you apply the formula here, it is integral of cosine x into secant x means 1 over cosine x and cosine x times of tan x means sin x by cosine x dx. So the solution for this is what now? That gives you integral of cosine x gets cancelled, right? In both the terms, it is integral of 1 plus sin x dx. So let us write down what is integral 1 means x, integral sin x means minus cosine x plus c. This is what the solution. I hope it's clear. Now let us have some more problems of this type. For example, I have a function of types integral of 7 times of sine of x by 3 dx is there. So take 7 outside and do integral of sine of x by 3 dx. So now that gives you 7 times of integral sine is what? Minus cosine. So it is minus cosine of x by 3 over x by 3 coefficient is what? 1 by 3 plus the constant. So now whenever there is a fraction in the denominator, we have to flip it. So it is 7 into 3, that is 21. Okay. So I will write directly 21 here. So that gives you 21 times of course negative sign is there. There is a negative also. So we write directly minus 21 times of cosine of x by 3 plus the constant. So this is what the solution for the problem. I hope it's clear. So how to do the term by term integrations. So I'll do one more problem on this term by term integration. Let us have a look about this. For example, I have another function as integral of root x over 2 plus 2 over root x dx. This problem number is 7th one. So now how will you solve this? So we can write this as 1 by 2 outside and root x means x to the power of half dx. And from the second term I can take 2 outside and write 1 over root x means x power minus half dx. So that gives you half times of x power half plus 1 over half plus 1 plus 2 times of x power minus half plus 1 over minus half plus 1 plus the constant. So now it is 1 over 2 times of x power 3 by 2 over 3 by 2 plus 2 times of x power half by half plus the constant. So here when we flip it, 1 by 2 times of 2 by 3 times of x power 3 by 2 plus 2 times of 2 by 1 times of x power half plus the constant. So what it gives us now? 1, 2 and 2 gets cancelled. Remain with 1 by 3 times of x power 3 by 2 plus 4 times of x power half plus the constant. This is what the solution. I hope it's clear all of you how to do the term by term integration. I have cleared with the algebraic functions and the trigonometrical functions in this. So I hope you could understand term by term integration. Thank you.